Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, and retired from the University of Albany, and his brother, me, Joel Chaiken. We're here to help you approach SAT math questions. Today we have a big announcement. We just hit over 100 subscribers to our new YouTube channel, which started in middle of August 2022. Thank you, everyone, for listening and subscribing, and we appreciate that. Hopefully, you're getting something out of this. And not only that, today is Throwback Thursday, so we will go back and we will look at a question from 20 years ago to compare and contrast it to current SAT, and you'll be happy that you are now taking the current SAT. Okay, so this is a question from the current SAT. We do Throwback Thursday after this as a bonus. Of course, turn it off if you don't want to see it. So this is from the calculator section. See, calculator. Okay, here we go. Coastal geologist estimates that a certain country's beaches are eroding. Oh, it's got some sort of political correctness here. At a rate of 100.5 feet per year. How long, to the geologist's estimate, will it take in years for the country's beaches to erode 21 feet? Wow. Okay. I mean, isn't this just standard? Y equals mx plus b, linear equation thing? I mean, isn't it just like that?
No, it's not even. It's the things. It's losing 1.5 feet per year.
Oh, you're right. It's not.
During a certain period of time, it loses a total of 21 feet.
Yeah.
It's simply how many 1.5 feet, which constitutes a year, fits into 21.
Right.
So you don't even, you do 1.5, and you divide it, you divide 21 divided by 1.5.
Wow.
Which is also known as 21 divided by 1.5. And you could cancel the threes. You divide both sides by 3 and get 5.5 here and 7 here. 7 over 0.5, which is also 7 over 1/2, which is 14. And the units of years. Why are the units of years? We have 21 feet divided by 15 feet per year. Feet divided by feet cancel out. Unit divided by 1 over year, you get years, the units of years.
Well, I think you're going a little bit too... Like you made a little bit.
This is not an algebra question.
Of course, it's an algebra question. It's a ratio question. It's a ratio problem.
It's a word problem. If something happens, I work for 3 hours and I get $5 an hour. How much do I get? And then that's multiplication. It's a division question.
Yeah, but the division questions sometimes are confusing. And maybe
this one is easy. This one isn't confusing.
Well, if instead of this, you know what I would have said? If you're going to go this route, I would have done 1.5x equals 21.
Yeah.
And then x is equal to 21 divided by 1.5. If you want to do it as a more methodical ratio problem,
What if you're doing it in a party?
Wait.
What if you said, if you were standing around a party and you said, hey, our beach is eroding 1.5 feet in a year. Well, I just had a kid, and when my kids reaches drinking age, well, how many?
Yeah, that's easy.
No, and it's 21 feet to my beach house. How many years do I have?
Right. Notice you changed it.
When you try to do it in your head.
Right. You may get it wrong because it's a division thing. The easier one was the one you said. My kid's going to be in 21 years. How far will it go?
Yeah, that's a different... No, sorry. I'm trying to make up a new problem, which is harder than solving a problem they give you.
No. Look.
Okay. think we nailed this
we're
one.
just spinning our wheels here.
There's
But
a little, there's a little bit of a taste of algebra here. You can give him.
Maybe a little bit of a taste.
Hey, this is how you could write it out in algebra.
Yeah, you should. But the thing is, you want to practice on simple, not practice, but you want to get in the habit of even doing the simple problems with algebra, particularly on this SAT, because you really want to have everything done methodically. But yeah, you could cut corners and do it the way Seth did it.
And you bang it out. Yeah, and this is also, Joel and I would differ, but I think I would agree with him that if you're if you don't see how to do the division, the arithmetic of the division right away, you plug it in your calculator. 21 divide 0.5 equals bing, you get it.
Yeah, I was going to say that, but I forgot it was a calculator.
Divide by 1.5. Yeah. I said 0.5, I meant 1. 21 divide symbol 1 period 5 equals bingo 14. Right. You're done.
Right. See, I forgot actually that this was a calculated question. I was going to end today, so I'll end sooner. And what happens if this is not what do you do when this is not a calculated question? That's dividing by a decimal. It's a little harder, but Seth is right. If you have this, you just go directly to the calculator, because when you divide by a decimal, you have to be careful. You can't divide by a decimal. It's 210 divided by 15. Remember, you can't ever have a decimal in the denominator.
You multiply both sides by 2 and get 42 over 3.
Oh, that's the smart way.
Put the 3 in, then you do 3 into 42.
Yeah, which is 21.
Which is 1, the remainder of 10. 3 14. Into 12 is how much? 4. Get the same answer.
Yeah, 14. Yeah. Right. Yeah. Do you notice, as I said 21, I actually made a mistake. Seth and I talked about this very often. You all make mistakes in doing math. Just hopefully you don't get the wrong answer, because I noticed I made a tiny little mistake.
Well, hopefully you realize what your mistake is.
Yeah, right.
Like the mistake I did. I tried to make up a question involving a 21, and I took 21 to be the amount of years.
Right. Yeah, which was the.
But the problem, 21 is the amount of erosion in feet.
That's right. In fact, I think it's very natural when you do math.
But then it was, it's not working.
Well, I reminded you.
Doesn't make sense.
Yeah. So anyway, it's a calculated question, so you can get away with not having to actually know how to do 21 divided by a decimal. But you should know how to divide by decimal. Seth played a cute trick here by multiplying both sides by 2. That was really smart.
By 3. By 2. Yeah, by 2. By 2.
See, Seth made a mistake.
That's because I know 1.5 is 3 halves. 1.5 is 3 halves, yeah.
Yeah, and Seth used this idea of the complex fraction, right? 7 divided by a half. Is 7 a number divided by a fraction is the number multiplied by the reciprocal of the denominator.
Yeah.
So remember the complex fraction rule. Okay, we really killed this time. We better go.
We better go
before we drive people even more
Time
crazy.
To move on.
So then, thank you, everyone. We're going to do Throwback Thursday, but we have to say goodbye. Boilerplate. Have a good day, and please like us, dislike us, give us your comments, and email us questions to SAT Math Question of the Day at gmail.com, which we only check like once every week or two. So be patient, but if we don't get back to you immediately. Okay, welcome to Throwback Thursday. Back to a test that was probably given in the early 2000s, maybe 2001, 2002, 2003. Oh my God, look at this answer sheet. Can you believe that? Oh my goodness. Welcome. Wow. It's got multiple page answer sheets. Oh, this is crazy stuff. Crazy stuff they did that many years ago. Actually, not that many years ago. Here it is. Here's our question, which we looked at before. So, a question like this, it's possible. I mean, it's a percent question. There's no reason why they can't put this on the test, but it just seems too hard to be on a modern test. Okay. Wish us luck. Throwback Thursday. Here we are.
All right, should I try it?
I guess so. Yeah.
Okay. Let's just translate the English to algebra.
Okay.
So the ratio of A to B is 2 to 3.
Okay.
And I'll just keep in my back of my mind that A and B are positive.
Okay.
Now, Now we have an X and a Y.
Right.
It says, let me write down what happens if X is whatever.
Okay.
So I shall write X equals A increased by 50% of A.
Okay.
Well, 50% of A is what happened?
Did I put A frozen?
Oh.
Oh, what happened? Oh, that is
The
not
thing
good.
rotated.
Oh, that's crazy. That's crazy. How could that have happened? That's insane. Oh, wow. That is totally crazy. Oh, no. What are we going to do?
Should I try undoing? Click undo?
Yeah. Click undo, yeah. Oh,
it's just undoing my writing. I have like a plus.
Wait, what is going on? It's like, this is totally...
Oh, you know what's happening? I'm using...
Wait, what are you using?
I am using another button on my stylus.
Bad. Hold on. I think there's a way... Oh, this is... No, wait. I think there's a way to rotate it. Oh, shoot. Come on. Oh, come on. There's a way to rotate
Okay, guaranteed this will not happen when you take the SAT.
This is really embarrassing, but now everyone has more time to... Wait, there's a way to do this.
I don't remember.
There it is. There's the clicky thing. See, there it is. There's the thing to rotate it. Come on. There it is. See?
What should I do?
No, don't do anything.
You do it.
I'm going to try. Ah. Come on.
And now it's upside down.
We're getting it.
One more time.
Oh, this is so exciting. One more time. Oh, we're such fools. Okay. Come on.
What?
We're only as good as the computer. Wait. What am I doing? There, we got it. Okay. We're back in business.
Okay, good. All right, we're back in business.
Whatever you do, don't do it again. Okay.
All right, I won't do it again. Yeah, okay, let's redo. We'll do a redo. Okay, wait. Something.
I hate computers.
Something is. I'm not getting the same area. I'm getting a. I have a plus symbol instead of I'm getting a plus symbol instead of a pen.
God. A plus
symbol. What should we do here?
It's sideways, okay? I'll write it. All right,
you're okay. I'll dictate you right.
Go ahead.
But you write exactly what I say.
I promise.
Okay. A over B.
Okay.
Equals 2 over 3.
Got it. Okay.
Now, X equals A plus 0.5A.
Got it.
And Y equals B minus 0.5A.
No, 0.5B.
B, okay, you're right, yeah. Yeah, Y equals B minus 0.5B, right.
Caught you. Okay.
Now write X over Y equals, okay, I think of something. To the right of A plus 0.5A,
okay,
write down 1.5A.
Okay.
And with an equal sign.
Okay.
No, on the left of it. Because they're equal.
Oh, right. Okay. Yeah. Oh, we're combining like terms.
Yeah, combining 1.5. And then what's 1 minus a half? That's a half.
Yeah, I can do that.
B,
Oh
point
my
five
God,
B.
we're like, come on,
Same mistake I
it's
made.
11:03 Eastern time.
Okay.
We're both tired. Okay.
So x over y equals 1.5 divided by 0.5 times a over b.
Oh wow, you are
Okay.
so smart, Seth.
And now write down, cross out the a over b and write 2 over 3.
Well, yeah, 1 point. Let's do one step at a time.
Okay, you got it, yeah.
Substitute 2
write down the 2 and the 3.
Okay, good.
And cancel like crazy. You could cancel the 3 out of the 15 and get
1.5. See, Seth made another mistake. It's 1.5, not a 15.
Yeah.
Yeah. So
1.5.
Yeah, so it's 0.5 times 2 divided by 0.5. Is that right? Am I doing it right?
Oh, yeah. The 0.5s cancel, and the answer is 2.
Right. Now, it's like word froze for a second. Everyone be patient. But yeah, the answer is 2, right? Wow, Seth. Nice and clean. Nice and clean. You might have made a few mistakes along the way, but you would have caught them. If you were doing them yourself, you would have caught it. Yeah. Wow. That's really cool.
Yeah.
Great. So then, yeah, Seth just methodically did translating English into math, and he stayed calm. How'd you stay so calm with that one? You just how'd you know it was going to work out?
I knew that there's a temptation to get nervous and try to take shortcuts and make mistakes, because this is a somewhat unusual thing to do in algebra compared to what you do on the SAT.
No, so compared to what you do, not what you do in school. Oh no, compared to what you do in SAT. You mean on the more modern SAT?
Yeah.
The more modern SAT, yeah.
I guess on the old SAT, they had a wider range of combinations of things to express an algebra.
Right.
You're taking a quotient of two sums. Right.
Yeah. I mean, I would have been tempted to do two equations, say 3a is equal to 2b, which means a is equal to 2b over 3, and then substitute it in here. Right? I would have been tempted to do that.
Well, I got the clue. Here's the thing. I got the clue.
Yeah.
Because first they started with a ratio of a to b.
Yeah.
Then they started talking about x's and a's and b's, and then the question was for a ratio of x and y. So I figured it's best to keep the ratios around as much as possible.
Yeah, good idea. Yeah, see, that's where intuition and sort of having Seth, you've been doing math for a while, right?
Yeah.
Yeah, so that's what comes with the experience of sort of like having a tremendous intuition on how to do these things. Keeps you, yeah.
So everything there is homogeneous.
Yeah.
If you multiplied all of the variables, right, x, y, a, and b, it's all four of them. You multiply them by the same number, like 17, you get exactly the same problem.
Yeah. Wow. Cool.
There's a homogeneous equations, where there's what's relevant about the terms in a homogeneous polynomial are the ratios of the coefficients, the ratios of the terms. The ratios of the terms are what's relevant when the terms are homogeneous.
Got it.
The homogeneous means the degree of the variables in each in each term. The degrees of the variables are the same.
Um,
Like x plus y, x plus 3y. X plus 3y is homogeneous. X plus 3y squared is not homogeneous.
oh, okay, yeah, yeah.
Yeah.
Um,
Okay.
I mean, if you wanted to do the substitution thing, A is 2/3 B, so it actually
Yeah.
works out very nicely. I'm going to change the color. If you
Yeah.
wanted to do that way, you would do X over Y is 1.5 over a half B,
Yeah.
but A is 3 over 2B. This is like, and you could change this 1.5. So you can change that 1.5 to 3 over 2 times 2 over 3B.
Yeah.
Oh my God! Look at that.
Yeah.
The 3's cancel, the B's cancel, and you have 1 over a half, which we did before actually. 1 over a half is 1 divided by a half, which is 2. So you could have done. You could have used this to substitute in. And people, it's a mess where I did it. But people followed. Maybe you followed me when I did it. So that's another way to do it. But I like the way you.
Yeah.
Oh, look at that. When I. Oh yeah. So you definitely need to do this. This is critical, right? That's absolutely critical. You have to know about percents. Oops, Seth froze, but he'll be back. You absolutely have to know about percents there. Come on, Seth. Come on back. Internet. Come on. Come on. Okay. So anyway, yeah. We haven't been, this computer's been generally okay with internet recently, but now it's not. Yeah, this is really frustrating. What's that? Hello? So anyway, you have to know something about the percent. You have to know when something's increased by a certain percent and decreased by a certain percent. Okay. Is Seth going to come back? Come on, internet. Come on. What are we going to do? Seth's talking, but he doesn't.
When people, you don't hear me? What?
No, you've been lost for a while. The internet's horrible here, and for some reason, it's very bad.
Oh.
And we can't redo this. This is too long of a video for us to redo. So, wow.
Bye-bye.
Okay, so Seth, I think you're live now. You want to say something?
Testing 1, 2, 3.
Yeah, now you're okay. So talk fast before the internet dies again.
Well, we're selling this car for 10% off.
Right.
They don't say we're selling this car for the regular price decreased by 10% of the regular price.
Right.
Well, they'll simply say, well, we're selling this car for the regular price decreased by 10%. Well, when someone says the price A decreased by 10%, they mean what's subtracted is 10% of A. What's not, it doesn't mean whatever A is, like 38, minus 10%. 10% is 1/10. That's not the normal usage of percent.
Wait, are you saying?
But in this problem, they made it very, very exact, and they didn't leave it to you to apply ordinary, rather imprecise language for the usage of percent.
Oh yeah.
By translating what was written in English into algebra exactly, we solved the problem most easily.
Yeah, that was really good. Yeah. Percent problems always are. Yeah, you have to be careful with percent problems. But you're right; they were really explicit here. So give him credit for that.
Yeah.
You need all you can get help with the older.
Maybe they didn't want any wise guy objecting.
Yeah, but don't forget those.
A might be a fraction. A might be a proportion.
Yeah.
And then indeed sometimes if like have you say you give it a proportion like 5%. They say, well, interest rates are going up. How much? By 1%. That means an old interest rate of 5% becomes 6%.
Right.
It's not that's going up by 1% of 5%.
Right. So in other words, it's right. They are not. That could be potentially ambiguous.
Right.
Yeah. So
yeah.
they were careful here. Okay, that's good.
Which they should be.
Yeah. Good. Okay. Wow. So we got through another Throwback Thursday, except the internet didn't cooperate. But anyway, hopefully people still got something out of this. Okay. So.
Okay.
We'll see you tomorrow, hopefully, and have a great day. Okay.
Yeah.
Bye. Bye.